Hello, everyone. I'm Yunyi Zhang, a postdoctoral researcher at Tsinghua University. My primary research interest lies in DNS security. I sincerely apologize that due to these issues, I'm unable to present the talk in person. This work presents a top-down analysis of domain name registration from the perspective of domain registries. Through empirical analysis, we identified three flawed operational practices spanning the domain lifecycle, including creation, management, and deletion. These flaws are present in 6 major registry backends and impact over 1 million domain names. Domain names serve as essential digital identifiers in our daily lives. Users acquire domain names through registrars such as GoDaddy or Namecheap. But the ultimate authority of domain registrations lies with domain registries like Verisign. They are responsible for managing top-level domains and maintaining the integrity of registration records. Because registries oversee the entire namespace, any vulnerabilities or misconfiguration at the registry level can have widespread impacts. Registrars and registries exchange domain name, date, and manage the domain lifecycle through the Extensible Provisioning Protocol. EPP status code reflects the domain lifecycle phases and what actions are allowed. The table shows some status code. We all know that a domain has to be registered before it can be used, but we found something strange. Some domains are accessible even though they are not registered. In the slide, we show an example. The domain on the left is registered with Alibaba Cloud. And its website works as expected. But for the domain on the right, we can't find any registration date, but its website is still online. It's very strange. Quite old right. We suspect there may be some unrecorded activity at the registry level causing this. Previous incidents have shown threats involving domain management. In the slide, we show 2 examples. Previous studies show that undocumented operations at some registries left a large number of domains vulnerable to hijacking. And in 2023, a blog post reveals flaws in EPP server implementations that could allow attacks to gain control over the entire top-level domains. Building on these incidents, we attempt to conduct a thorough analysis of how domain registries operate. But until now, registry security is still underexplored, mainly because EPP implementations were and are often opaque, and the access is limited. We set out to find a way to rapidly explore internal operations using public data like the TLD files, registration records, and registrar interfaces. Here we give an example. We observe that all changes to domain delegation records ultimately involve the registry, either supporting a request from the registrant or registrar or initiating the update itself. Building on these ideas, we designed the following analysis process. First, we collect files from over 1,000 top-level domains and over 7 billion domain registration records. Next, we extracted delegation records and checked each domain's extension and registration schedules. Finally, we analyzed the operation flows across 3 key phases: domain creation, management, and deletion. Through this process, we uncovered the 3 flaws in registry operations. In the domain creation phase, we found an interesting issue. When someone registers an international domain name, and some registries or registrars automatically add the corresponding IDN variant to the identifier and configure both domains with identical name servers without informing the recipient. We call the registered domain variant a turn domain. The concern is that we found attacks can explore turn domains for malicious purpose at zero cost. Here is how it works. If a registrant hosts their primary domain with a provider that allows users to deploy any domains without ownership verification, and the registry or registrar automatically syncs the same name server settings to the turn domain. Then the turn domain is also dedicated to the provider. At the point, an attacker can simply claim the turn domains on the same hosting platform and point it to a malicious IP. Finally, we found over 8,000 pairs of turn domain, and more than 6,000 of them were at risk of being taken over. Even more concerning, we discovered some turn domains were already being actively abused. As the example here, one of them was used for a range of malicious activities, all within just a single month. During the domain management phase, we noticed some unusual. Some registries add every host object submitted by registrars directly into the loom file without doing purpose checks or cleanup. Through this driver analysis, we summarize 2 common modes that registry hands host objects. One mode is to add them to the files as soon as they are registered. For example, the top and com. The other is more cautious. It only adds them when they are actually used in an in-domain delegation. Use the method we introduced before to identify steel glue records. We analyzed the over 1,000 top-level domains and found that Model 1 led to around 80,000 steel glue records that attacks could potentially exploit. Our findings show that the registry's glue records management strategy is the key factor behind the large number of steel glue records. Let's review the domain name lifecycle. When a domain expires, the registry is supposed to clean up all the resource records linked to it. But what if that cleanup doesn't happen properly? What could go wrong? We found that in some cases, even after the domain expires, its delegation records are still left behind in the loom file. We call these relic domains. Depending on their current status, we break them into types: untaped and resurrected relic domains. Untaped relic domains hadn't been re-registered after expanding. Since there is no admin anymore, their delegation records just cite in the files. And resurrected relic demands have been re-rejected, but the new registrar doesn't control the old delegation records. They can add new ones, but they can't remove the leftover automobile records. The table shows examples of resource records and registration status for both types. By looking at the delegation records and the status dates, we've found over 3,000 interpreted relic demands across the 11 TLDs like .top, .f, and .vip. We also identified 19 resurrected record relic demands spread across the 13 TLDs. Altogether, these cases involve 6 major registry backends, including big names like Google and ZDS. And finally, we found the affected registry backends serve a total of 812 TLDs. To think out what was causing these relaxed demands, we teamed up with a registry service provider. We found that when a demand enters the pending delete phase and also has a server holder status, due to some issue, the overlap between these two statuses can confuse the system. As a result, the software fails to properly delete the delegation records. Finally, we have disclosed this issue to all affected registries. Currently, both Google and VDS have identified the problem and fixed it. Whether caused by restrictions, registrars, or registries, operational actions ultimately lead to steal or dangling resource record. We all agree that these records are harmful. Yes, we will learn sidestep the issue, attributing it to user error. Let's recall the dangling risk was first highlighted in 2016, and new variants continue to emerge in recent years. Moreover, evidence shows this risk is already being widely exploited. It's time we addressed it with correct technical mitigations. None of us want to find ourselves still grappling with this threat a decade from now. Some providers, such as AWS and Google, have already made significant efforts. They employ secure DNS allocation algorithms to prevent attacks from acquiring the necessary resources. However, many other providers lack similarly large infrastructure pools to implement such a strategy. The core of the dangling records threat lies in the fact that resource records associated with discontinued service are not properly cleaned up. To address this, we propose a verification strategy called double clear. When a user intends to host a domain, we recommend that the provider first performs an DNS check to verify if any studio or Linux DNS record exists. The goal of this step is to prevent vulnerable domains from being exploited by malicious actors. Next, when a user attempts to console a hosted service, the provider adds an extra verification steps to confirm that the user has already deleted and or updated the relevant resource records. This approach informs cleanup of obsolete records as a source, while remaining compatible with existing provider workflows. The proposal had already gained recognition from several providers, and when interested in the technical details is welcome to contact us directly. That's all my presentation. Thank you so much for your attention.